right, my third grade mathematicians, we found many ways to make a whole yellow hexagon. So remember, we were pretending these were cookies and we were dividing them in equal fractional pieces and then combining different fractional pieces to make one whole hexagon. So remember to add that to your chart of ways to make one whole as we continue with our fraction learning. All right, so do you remember which pattern block is half of a cookie? So I've got my pattern blocks here. Do you remember which pattern block was 1/2? You're right, it was the trapezoid. It takes 2 trapezoids to make one whole hexagon cookie. Okay? So one trapezoid would be 1 out of 2 equal parts to the whole. So one trapezoid is 1/2. Now, I'm going to put this one back over here, and here's what I want you to think about. What are ways that you can make 1/2 of a cookie with a fractional piece, with other fractional pieces? So we have 1/2. How can we use these other pattern blocks to make exactly 1/2? So take a minute and pause the video and try with your pattern blocks how you can make 1/2 with other fractional pieces. Did you pause the video? If not, go ahead and pause the video and take time to figure out different combinations or different solutions to 1/2. All right, so if you are ready, let's talk about some ways we can make 1/2. All right, so for 1/2, I'm going to try using, let's see, my 1/6. Okay, because remember it takes 6 equal triangles to make one whole hexagon. So how many triangles do you think would make 1/2? Let's see. Oh, I got it there. 3. 3 1/6 triangles would make 1/2 of a hexagon, and it would equal one trapezoid, 1/2. So how would we write that as an equation? Let's see here. Get my black marker and my board. So I have 3 triangles. So one triangle is 1/6. My second triangle is another 6. And my third triangle is 1/6. So 1/6 plus 1/6 plus 1/6 is going to equal 1/2. Since these have the same denominators, I have 3 1/6. So I can write that as 3/6. I have 3 1/6 size pieces. 3/6 equals 1/2. These are called equivalent fractions. Equivalent fractions means the same amount. So if I'm thinking of our hexagon cookie, and my friend Ella has 3/6 of a hexagon cookie, and I have 1/2 of a hexagon cookie, we both have the same amount. They're equal. Okay? All right, so any other combinations that you found to make 1/2? Let's look here. Let me go back to my pattern blocks. I'm going to try the rhombus here. Don't think I can make 2 rhombuses equal exactly 1/2. But I can use a rhombus and a triangle. So what fractional pieces is a rhombus and a triangle to the hexagon? Well, we know the triangle is 1/6. What was the rhombus? 1/3, because it takes 3 equal rhombuses to make one whole hexagon. So each rhombus would be 1/3. So that equation would look like this. 1/3 plus 1/6 equals 1/2. Okay? All right. All right, so now what I want you to think about, this is just a wondering I had, and actually it was a question posed to me. Can you show 1/4 of a yellow cookie with the pattern blocks? So with the pattern blocks that you have, can you show 1/4? So with the pattern blocks that I have, I can't make 4 equal parts. You can make 4 equal parts if you divided this hexagon cookie, but we don't have a pattern block that would be exactly 1/4, okay? So we have, remember, the trapezoid is 1/2. The rhombus is 1/3 because it takes 3 of these to make one whole. So one rhombus is 1/3, and then the triangle is 1/6 because it takes 6 to make one whole hexagon. Okay? And then we also talked about equivalent fractions. Fractions that represent the same amount. 3/6 equal 1/2. So before I let you go, looking at these pattern blocks, have you found any other equivalent fractions? Well, when I was finding fractions that equal 1/2, I saw before I put that third triangle that these two triangles equaled or looked like one rhombus. And I know it doesn't really, there we go. That two triangles equal one rhombus. So the fractional pieces here, I have a 1/6 and a 1/6. So the equation would look like this. One-sixth plus 1/6 would equal 1/3. Because these have the same denominators and are divided in the same way, I have two 1/6 pieces. 2/6 equals 1/3. So we have another pair of equivalent fractions. Okay? All right. So as we go along, we're going to make a chart where we're finding these equivalent fractions. Okay? Now also, not just with the pattern blocks, I want to double check with my fraction tiles to see if these equivalent fractions are true. Okay, so if I have 1/2, I want to double check and make 3/6. See if 3/6 is equal to 1/2. Yep, 1/2 is equal to 3/6. All right, so another equivalent fraction I found was that 1/2 was also equal to 1/3 and 1/6. Yep, that's true too. There's no gaps and overlaps. And then we also said, and I can even pull this from the half, that 2/6 is equal to 1/3. Okay? Wonder how many sixths we would need to equal 2/3. Well, let's see here. If 1/3 is equal to 2/6, this third would need 2/6. So 2/3 is equal to 4/6. Just like I said before, if I'm eating a chocolate bar and my friend Ella ate 4/6 of a chocolate bar and I ate 2/3, we still ate the same amount. We just divided it in different ways. Okay? So like I said, we are going to be making a chart that show or that record our equivalent fractions. Okay, so we have equivalent fractions. And so far we have found 3/6 equals 1/2. 1/3 equals 2/6. 2/3 equals 4/6. As we continue, I want you to think about why these fractions, not only we can see in our hexagon cookies or our fraction tiles, but by looking at the fractions themselves, do you see any relationships between the numerators and the denominators? Okay, so tomorrow what we are going to do, we're going to look at fractions on a number line. And so when we do that, we also are going to be looking at equivalent fractions. All right, guys, thank you for your hard work today, and I'll see you tomorrow.